So, let's wait for this to load. We'll just set up a few basic things in the build definition. So one of the things that TeamCity does out of the box is your build number format. It'll give you a nice little number that just increments for every build that you run, which is cool. But the problem with this is if you're using semantic versioning, it means that you'll be your packages will be jumping a major version number for each build, which may be bad, especially if you're doing things like generating NuGet packages. So the first thing I usually do is come in here and remove that and replace it with a parameter called version. So the TeamCity parameter format, it uses percents on the start and the end of things to indicate that they're a parameter that's coming from somewhere. If you put a parameter in that doesn't exist, it'll automatically create it for you. So that's what we're going to do now. So if everyone can put in the parameter version under the build number format, this is under general settings. We'll have a look at what that's going to do. And then say, you don't have, it's right there, I can see it. Okay, so I'll move on. So now if we go into the parameters tab, now if we go into if you click save first, unlike me, and you go into the parameters tab, you'll see that there's now been a parameter automatically created with that's got a value there, a value is required. So it'll create a parameter for you and you'll have to go in there and populate it somewhere. So I like to use semantic versioning, so we'll give that a version of 1.0 and then the build counter. So what this will do is it'll give us nice semantic versioning and it'll increment our patch number every time we run a build as opposed to the major version number, which it would have done before. Some people like to control the major and minor version numbers in source control. I think that's a good idea. There's a lot of advantages to that, especially if you're doing a lot of branching. And especially if you're working on applications that have long release cycles and you need to have a branch per version number and things like that, it can get quite useful. But in a CD environment, I find it's annoying. It's very rarely in CD environments that you actually use the version number or major and minor version numbers to the extent that you would in things like a Windows application or something like that, where you may have multiple copies running in production. That being said, if you're working on some kind of web app that's deployed on site at customers' sites, it might make sense when you have a large number of different copies running in the field. But if you're working on some kind of SaaS solution, it's probably going to be pretty pointless to have your version numbers and source control. You can still come in here and increment the major and minor versions in editing the parameters in TeamCity when you need to. So I find it's a lot more convenient. So after you've done that, hit save, and that'll give us some nice semantic versioning in the build. So the other thing that I'm going to point out to do with versioning as well is with the build features. So build features in TeamCity are just little things that you can add on. They generally run right at the start or right at the end, depending on what the feature is. And one of the features that I think is very essential in .NET is the assembly info patcher. So if you go into build features and hit add, and we'll have a look at this one. So the assembly info patcher, what it does is it will go through all of your source files before your build executes and look for assemblyinfo.cs files or .vb files if you're unlucky enough to work on VB, and replace the version number in those with the version number that you choose. So what we can do here with that version number parameter that we created, we can put it in here, and then that way our build number in TeamCity is going to be the same number that's then stamped on the DLLs that we're compiling, which is really great if you're troubleshooting production issues to be able to go, okay, let's look at the version number of that DLL and be able to go straight back to the build in TeamCity that it was built from. So it has that nice linking of version numbers that will carry through from your build system all the way through to production. So what we'll do in here is just punch in version. So you'll see now that the autocomplete starts to pick up version because it's been added as a parameter. So we'll put in version for all three options there. So some of these version formats accept the full semantic standard where you can put a dash for alpha packages and things like that, and one of them doesn't. I can never remember which one it is. I think it's the file version format. It only supports like the numbers and dots. So if you're doing something like that, be wary. Okay. So the next thing that I want to talk about with our build is we're just going to cheat a bit and go ahead while we're in here. There is a build file cleaner. So if you just go to add that guy. So the reason we're going to add this is one of the things that TeamCity does on its agents is when it executes your build, it will create a unique folder for that particular build definition. It will shove your files in there, and it'll keep that cache there. The reason it keeps that cache there is because of package management systems, things like NuGet. So on the build agent, you'll have a similar environment to what you do on a developer's local, where you've got this packages folder where all your packages go in, and you never clean that up. There is options in TeamCity where you can force a clean build, where it will clean out that folder if you need to, but it maintains that cache there to increase the speed. It doesn't work with NPM though. I'm still a bit perplexed about that. One of the problems with this that we run into is if you're doing things like generating artifacts that you then want to send to an artifact server, it will, especially if they're version numbered files, this artifact or the folder where you output your artifacts to is just going to grow and grow and grow, and it'll never get cleaned up. So the build files cleaner is what we use to clean out, to manually force folders in the agent directory to get cleaned out as a part of the build. So I can't remember if this runs at the start or the end. I think it's the start of the build it runs at, and then it'll make sure that from the previous build it flushes out the artifact. So the path we're going to use here is octopact, which is the default octopus output path for its packages. So if you just put in octopact there, what that'll do is it'll look for that folder in the root, and anything underneath that, it'll clear it out at the start of each build. Yep.
You could increase the font size.
Font size?
Yeah. Forward replacing.
How's that? I might try and paste some of the text into the Slack channel as I'm going to make it easier for you guys. Because some of the stuff that I'm going to bring up soon is things like big long connection strings that you don't want to be typing out manually. So, next one. So the next thing I want to talk about is the VCS roots and triggers. So We've got the VCS stands for version control system. TeamCity tries to be a little bit agnostic about the version control system to make it easier for people that have multiple systems or are transitioning from one to the other. So basically, the VCS routes it tries to make them similar. So if we go in and edit our VCS route here, what I want to bring your attention to is this branch specification. So the branch specification is basically in the VCS route what branches this build definition cares about. So normally all you really care about in GitHub is your pull requests and maybe your master branch. So what we want to do is basically ignore all the other branches because while someone's doing their dev work on some branch that they have, they might be pushing to their branch in Git because it's Friday afternoon, they're going away for the weekend, so they want to back up or something like that, and they may not want all of your continuous integration to run on every commit they send to some random branch. So the easiest way that a lot of teams deal with this is they just run the builds on the pull requests. And so basically when you're ready and you'll finish your development work is when you create the pull request. So where some people go wrong is they create pull requests after everything is finished. So I'm ready to merge to master, that means I need to create a pull request. That's the wrong time. You should be creating a pull request when you're ready to go through whatever QA processes or test automation that you're ready. When you're ready for a code review, that's the time that's what pull requests are for. So the branch specification we're going to create is let's put it in as a parameter so we can get some more. So put a parameter in called branch spec. And then we'll save him, and then we'll go to our parameters and see that it's come up in there. And here we go, branch spec. So the branch specification in TeamCity takes the form of basically your a list of branches. And let's go an example here. So you can use the standard TeamCity notation. You can go +:, and then put a branch specification in there. So I could go heads/master, and then I could do I could do something like refs heads master, or I could do refs heads star, and then minus refs heads master, which would be all of the branches except for master, something like that. So you can put it, there's a number of different options you can use. The one that we're going to use today is a bit weird when you look at it. So what we're telling it here is we want it to build master and our pull requests, but we want it to build only the merge reference from the pull requests. So, and the other thing that's a bit weird about this is these brackets. What are they for? So if you put in your branch specification something like this, refs heads master, in the UI for TeamCity, it will display the full refs heads master, which is not really user friendly. So what it allows you to do is put brackets in your branch specification like that. And what that'll do is it means in the UI, it will display only what's in the brackets, even though it's referring to the full branch specification. So in this example here, when it does a master build, the branch label that it's going to display is just master, which is a little bit more user friendly. So the merge reference in GitHub is something I'll talk about. This is a cool feature of GitHub. I think only GitHub and Bitbucket support this. What it basically is in Git systems, your pull requests or merge requests in GitLab they're called, they advertise a Git reference which is refs/pull/ and then the number of the pull request. In GitLab it's refs/merge/ the number of the merge request. So in GitHub it also advertises another one underneath that which is the number of the pull request /merge. So what this Git reference is the result if you merged into master. So what it does is it gets all the changes from master and your branch, merges them together and advertises them as this merge reference in Git. And we build off that because what that means is we can know before we merge to master, if our code was in master, would it break our test automation? Yeah. So yeah, if you guys want to put that in, I'll paste that one into the Slack to make it easy for you. So the next thing we'll have a look at is build triggers. So there's a number of different options with in TeamCity for the types of triggers you can do to kick off builds. You've got VCS triggers, which we'll have a look at now, but there's also things that I won't go into, like scheduled triggers, which is pretty obvious. Finished build triggers is how you chain your builds together. So if you have, you know, a build that runs first, and then other builds have to collect that build's artifacts and trigger themselves based on that, you can use finish build trigger to chain them together. Branch remote run trigger is a bit of a hack workaround for the TeamCity gating. And then there's a bunch of other ones. NuGet dependency trigger when NuGet's updated, stuff like that. So the VCS trigger is the main one that most people use. So what the VCS trigger is, it's just basically watches source control for changes and then triggers based on those. So we can also put a branch filter in here. So I won't put a branch filter in here, I'll leave it as everything because we already have a branch filter as a part of our branch specification that we put in the VCS root. So because the VCS root is only looking at the pull requests and master, that means inherently the VCS trigger will only trigger off those branches. So you can just hit save on that. Oh, the other thing to be aware of is it's got a quiet period mode, TeamCity, and the default's 60 seconds. You might want to reduce that. Let's leave it at 60 seconds because we've only got a one-core TeamCity server today. But you can reduce this. This just means that if you have a high volume of commits going into a branch, it's not going to build too much, which happens with Git systems because when people push, they push large numbers of commits usually. And so if you're using Git, don't check this box that says trigger a build on each check-in, because that means if you push 25 commits in one push, it'll run 25 builds. So yeah, just click save on that guy. So the other thing that we'll just have a quick look at is the project layout. So as I was saying before, we're going to build two packages today. There's it's the to-do sample app. There's lots of to-do sample apps available. I'm sure everyone's used or heard of the to-do samples. We've got a to-do CDN project. This is basically our project that's going to transpile and pack up a bunch of TypeScript using Webpack. And that content we're going to push to a CDN. And then we've got our other project here, which is a CS proj for .NET Core. This is using .NET Core 1.1, where they've moved back to using XML CS proj files. I don't know why. The xproj files are really cool. And it's also got some and then as well, there's also a test project in here which runs NUnit tests, and we've also got some TypeScript tests that we'll be running as well as a part of the build. so we'll have a look at those. The .NET Core is still not finished. I know a few people that are using it in production, but there's still a lot of things that don't work 100% with it. NUnit's one of them. We're still working on some changes to NUnit. An alpha version came out, I think it was only last week, that now supports the new testing stuff in .NET 1.1, which was recently released as well. So yeah, it's there's still a lot of supporting libraries that are a work in progress with Core, but we'll have a look at it today. Right, so yeah, so the to-do project is the C# Web API backend. It's got a deployment target of a cluster running IIS. The to-do test project was NUnit. Yeah. So I'll talk a little bit about CDNs. So CDNs are great for distributing static files close to your users. Like, I can't say enough how much of a performance impact CDNs have on users. We've been doing a lot of work with our CDN provider, Agoda, in recent months, and some of the performance gains that we can get out of moving stuff to the CDN and getting close to our users is just amazing. Especially here in this part of the region, you know, if you've got customers in places like Indonesia, you know, getting connections from Indonesia back to a decent data center in somewhere like Singapore isn't that easy. CDNs will allow you to have your endpoints a lot closer to the users in countries like that and get much better performance for them. But CDNs aren't all that great. So traditional CDN technologies updates take time to populate. CDNs have caching layer on top of caching layer on top of caching layer. It's how they work. So if you want to update a file, sometimes you can run into problems. Out of the box, from memory, CloudFront, which I haven't worked with for about a year or more, so I may be wrong in this, but from memory, if you're just a basic customer at AWS, you get 5 parallel force updates that you can run on files. So if you do have a problem where you've got a large amount of files that the cache needs to get updated on the CDN, it can become a problem. Akamai is better in that aspect, but they're still not perfect. So what do we do about this? A good way to handle it is always insert, never update when you're dealing with CDNs. If you add a new file to a CDN, the propagation is almost instant, whereas if you update files, it can take time. And this actually works better if you're working for static content, because if you've got resources like CSS and JavaScript, your browser is going to be caching them as well. So if you're adding a new file, when content's changing, it'll immediately, you know, you won't run into problems with browser cache because it's a new URL. So we're going to look at some of the features today of Webpack and how to handle this. So Webpack has a chunk hash feature built in, which adds the content-dependent hash to the file name or path. So content-dependent is important because if the content doesn't change, you don't want users re-downloading the file and updates. So for example, if you're I know a project I was dealing with a few years ago, the way they dealt with this is they just basically whacked the version number of the build they were running onto the end of each of their JavaScript files. That worked, I mean, but the problem was when they started to move to more frequent deployments, sometimes they wouldn't have any JavaScript changes in their files. So users would be re-downloading their files just because an update went through, not because there was new content set up. So the chunk hash feature in Webpack actually generates a hash based on the contents that's inside the file. There's also a commons chunk plugin, which we're going to have a look at today. So this bundles third-party content separately. So this is very important because as I was saying about JavaScript content not updating as you're deploying, your third-party libraries that you're using are probably not going to get updated as frequently as your own code, especially if you're pushing to production multiple times a day, like we do on the front end of Agoda. So what this allows us to do is basically our transpiled and bundled output. We generate one file which is our JavaScript code that we've written, and another one which is our third-party libraries, and stick that in another one. And the third-party libraries one probably won't change much, so the hash on that will remain consistent, and the users won't be re-downloading it every time we do a deployment. And the other one we're going to have a look at is how we link these things together. So the Asset Webpack plugin outputs a file. and we can pick this file up and package it with our C# project that we're going to bundle and send to the cluster. And so the reason for that is so it's aware of which JavaScript files it should be accessing. Because if we're pushing all of these JavaScript files up to the CDNs with different hashes, when we get our page from the C# project, when we get the page load, we have to know which JavaScript files to go and get. Okay, so making the Webpack in .NET work. So this is what I was just talking about. So this is the output that we get up the top. So the assets Webpack plugin, that's just the little JavaScript command in Webpack that we do, and that will then output this webpack-assets.json file. So that file we pick up in .NET as just part of the configuration, and then we define a class that basically tells us what the layout of that file is like, so we can dig in there and get the data out of it of where our JS file is for our JavaScript that we want to run on the page, our third-party JavaScript bundle file, and also CSS files and things like that if they're in those. So the Webpack, the thing that I like about .NET is for configuration, the app settings have moved to JSON format. It's awesome. You know, we've now got hierarchical app settings instead of just a flat dictionary like .NET used to have. This Webpack's asset.json outputs in JSON format as well, so we're able to pick that up like it's just a part of .NET's normal configuration. So debugging on your local like it's a CDN. So the other advantage to this is that in Visual Studio itself, we've got two web projects. So when we debug this application in Visual Studio, it's going to run up, it's going to spin up two websites in IIS Express. It's going to spin up one for our dynamic content and another one for our Webpack bundled content. And the advantage to this is that it's going to act like it will in production. So in production, we've got our CDN URL and we've got our web cluster domain, and they're separate domains. So this means that people aren't going to make mistakes like, you know, putting in relative paths if they were one project on their local that we were then splitting up when we send it to production like some people do. So in this aspect, what we do is we just basically have in our app settings, the address of where our CDN is. And in production, that'll be the actual CDN address, but on our local, it's just localhost on a different port to what our main application is running on. In the example that I've got, it's using IIS Express for both. If you are using React though, you'll probably want to move to using the Webpack dev server for the static content project. There's a lot of cool features that's got, like dynamic updating with the browser and stuff. But you can still get that advantage of that good separation on your local environment of having a different web server for your static content. So let's create the client-side build steps and have a look at them. So if we go back to our build in TeamCity, and we'll have a look at these as we're going through them. So what we're doing here is the first thing that we're going to have to add in is an npm install step. And so the npm install is just going to process what's in our package JSON, which is all these guys. So we're going to build steps. So in build steps, this is the actual actions that the build will perform. These are going to be things like your package management, actually building your code. If you've got other things like sending things to, you know, artifact repositories and so on. So we're going to add in a build step here. So the runner types, there's a lot that come out of the box with TeamCity. There's also a bunch that I've installed here. So TeamCity uses a plugin system. You can write your own runners if you like. And there's also heaps of open source ones available on GitHub. So one of the open source ones that's available is Node.js npm. So we're going to go with that one. Now, when you add this, it's quite deceptive because it puts multiple npm commands in this text box. and it looks like it can run multiple NPM commands in one step. It can't. You're only allowed to put one NPM command in this. As of TeamCity 9, they have a bug with this plugin, and no one's fixed it yet. But if there's any Java developers in the room that would like to fix it, it's an open source project, and you can just go and fix the bug. But I'm not a Java developer. So we're just going to run the npm install command. You don't have to put an npm, you just have to put an install, and that will run the command that goes through our dependencies that are in the package JSON file and downloads them to your node modules folder. So the other thing that we want to configure in here is the node, is the working directory. So the working directory of npm is something that we want to set in multiple steps that we're going to do. So we want to make it a variable, so that if we have to change the location of where we're running npm, it becomes quite easy. So in the working directory, put in a new variable, node working directory, and we'll go and update that after we've added a few more steps. Okay, so I'll save him. All right, and that's our npm install step. So the other step that we want to add is a step to run Webpack. So in our project JSON, we have the scripts here, Webpack. So we can use npm to execute Webpack from here. There is heaps of different ways that you can handle Webpack. You can handle it from a command line, you can handle it from gulp. I'm not saying that any one way is better. You can do it however you like. The other runner type to be aware of is TeamCity has command line runners as well, so you can just run a command line or a PowerShell script. But today, we'll just use npm. So I'll add another npm step in here, npm run Webpack, and to execute the script, you've got to say run. So you go run Webpack production. I just want to have a quick chat about this. This project has a Webpack production because it's not my project. I think if you've got like build steps where you're going, do this for production, do this for everything else, you're going to run into bugs in production that you can't replicate. Okay, it's a really bad way to go in my opinion. The only really things that change between your local and production is like your, like the database you're connecting to, or the APIs that you're connecting to might be a different address. And that's configuration information, which shouldn't really change the way you build things. So your build system should be production agnostic, in my opinion. And if you've got things like this, you maybe, I'd keep an eye out for it and question it. And then again, with this guy, we've got to put in the node working directory. So just paste in your parameter there, and you should get statement completion here as well. No, I don't. Hasn't updated yet. Cool. And when you're done with him, hit save. So the next guy that we're going to add, npm install. Why is there two of those? Is someone else editing my build? Yes, they are. Okay, so I think you're editing the wrong build. Yeah. Alright, so what you can do if you like, if you need to catch up, you can, on the build steps, you can copy them.
Okay.
So if you've got build steps in one build, you can copy them over to another. Again, this is a bit like copying code though. So we don't like to copy and paste code. We don't like to copy and paste build steps if you can avoid it too. So if you do find yourself using that feature, I would question if you should be using templates instead. So the next one we're going to look at is npm test, because we want to run our unit tests. So for this guy, we can just use the test. We don't have to do run, because it's one of the standard npm ones. So what this will do is it'll run the Webpack script test here, which just runs jest. And the other thing that I want to point out in here is this guy. Oh. If I get zoomed out again. So what this guy is I haven't found a unit testing library yet that doesn't support TeamCity. The way TeamCity integrates with things like unit testing libraries and a lot of other stuff is through the log parsing. So basically, TeamCity executes command lines or all sorts of things on your on its agents, and then it gets log output from what it's executing. And in that log output, it looks for special tokens that are the TeamCity tokens. And these tokens for the unit testing libraries is just basically, it's in the format of something like TeamCity ## open square bracket, and then a bunch of properties, which is data that you can pass in to tell it what event it is. And then TeamCity will parse that event and put it in its database. It has support for events like unit tests, or test is something that's very common. So it's got events for start test, test result, end test, and all sorts of stuff like that. And you can actually, if you're writing your own scripts, like a PowerShell script or bash script that you're dumping into a TeamCity step, you can output these steps yourselves to do things like fail to build. A common one is sometimes we just have silly mistakes that developers do, and we write a PowerShell script that will, I saw you wrote one a few months ago, didn't you?
Yeah.
Yeah, it was, what was the PowerShell step that you wrote? It was to check the pull request?
Check the pull request that include the experiment ID or not.
Yeah.
If it not, it will fail the test.
Yeah. Yeah, so we do this sort of like little scripts that we can write all the time, and we can output, well actually from PowerShell you can actually just throw an exception and it'll fail to build. But you can also output custom, and if you output it as a test format in the log files, TeamCity will give some detailed information to the user about why it broke and things like that. But we can see here the test result processor for Jest is the Jest TeamCity reporter. So what this basically does is the output from Jest will come in that format that TeamCity is expecting in the logs, and it'll just parse it and suck it into its database. So yeah, the npm command is test. Again, we need to put our node working directory in. So the working directory, and then save. And then what we'll do is go into our parameters and we'll put the path for our node working directory in. So for our node working directory, it's going to be, source to-do CDN. src/to-do CDN. Because to-do CDN is where our packages.json file lives. So that's where we execute npm. So I'll save him. And so now we've pretty much got a working build to the point where we're downloading our dependencies. We can run Webpack, transpile everything, build a package, and then run unit tests. So what we'll do is we'll just build him. So if you go back to build configuration home, the top right. So again, the top right switches you between basically view and edit mode. And then from in here, we can just click run. Before you click run though, have a look at your compatible agents. Has anyone got compatible agents 0? Okay. If you make a mistake with your parameters, sometimes it will come up with compatible agents 0. because it will refuse to run your build if your parameters aren't set that are required. So we can just run this guy. Some people are running already. So this is the Agents tab. While we're waiting for the builds to run, I'll just talk a little bit about this. I was actually a bit worried. Yeah, look at our build queue. Yay! Spicy dog, you ran 2 builds. Can you cancel one? So yeah, we'll go back to our agents here. We're going to get all sorts of errors. So I'll just talk a little bit about the agents. It's really easy to spin up build agents. Like I was saying, just uses the JVM. So you've just got to drop something on the machine and it hooks back to the TeamCity server and just starts working. As I was saying, you can see the little Windows logo here. Should I zoom that in? So these are all Windows build agents. It supports Linux, you have a little penguin icon, and Mac as well. And there's options there, like I was saying, for pools. We've only got one pool at the moment, which is like everything. But you can create multiple pools if you need to. The other thing that it has is cloud. I do want to talk about cloud because it's really cool. So you can connect TeamCity to AWS or Azure out of the box. You can also connect it to OpenStack, and it will basically elastically scale your build agents. So you can set rules on, you know, if the build queue hits X number, start spinning up your build agents. You can even get to the point. Does anyone here use AppVeyor? No? Anyone use AppVeyor for building? No? Okay, AppVeyor is one of the big cloud build providers. They basically spin up a build agent for every build that runs, which is pretty impressive. And your builds generally start within a few seconds. It's not that hard to do though, if you're using, with your virtualization, if you're using differencing disks. Yeah, so if you are, you know, if you are using Azure or AWS, I recommend checking it out. It'll help you during peak hours. How's our build queue going? Not too bad. How's everyone's builds going? Have we got failing or succeeding builds? Looks like we've got lots of successes. Cool. Here's a good one. So you can see here, this is the what I was talking about with the branch labels inside TeamCity. It's got a nice master instead of refs heads master, which is nicer for the user. So this is the build definition, and we can click into completed builds to view the logs if we need to. So we'll go in here and just have a look. So we've got a nice little overview here. You can see it's got test pass 16. So if we click into the test tab, this is because Jest has been outputting in the format that TeamCity likes. So we get this nice UI that we can use inside of TeamCity. We can, you can also do historical analysis on your unit test runs with this. Since version 10, it's had this lovely flaky test logic in it, so it tries to determine if you've got any flaky tests based on the test history. So the build logs here, it nicely groups your logs, even though they're a flat log format. It tries to determine how it should group them and just make it look a little bit nicer for you. So here's npm running. There it runs Webpack. You can see the output from Webpack there. And then the final step is running the tests. So I don't think it outputs the actual, yeah, it doesn't output exactly if you have a look at the raw logs, you might be able to see it, but TeamCity strips out that custom TeamCity text that it's looking for in the logs before it displays them to you in the UI, so it doesn't get too messy, because the logs that TeamCity parses are quite verbose. I was helping out with the end unit guys with some of this stuff, and it's, when you actually read or when you get end unit to output with the -- TeamCity, it's really verbose. So Yeah, we've got a working build. So, has anyone got failed builds that they need to deal with before I go on?
My build is
Your build's failing? Is it from dodgy code?
what type of production step?
This one?
Yeah.
Ooh, NPM is failing. Okay, this is because package.json is not in the root. Your node modules folder is probably incorrect. Yeah, source to CDN, which is correct, but if we have a look at the build steps, node working directory. Missing. There you go. So I check all 3 steps and make sure they're correct. Alright, cool. Well, we'll keep going then. So, what do we have next? So one of the things to point out, NPM's not taking very long on our builds because we don't have a lot of dependencies. But on some of the projects I've worked on, working with TeamCity and NPM in the past, it does take a long time. The reason for this is TeamCity doesn't play well with the node modules folder. I don't know why. It's meant to leave it there, but it seems to clean it up. And I can't figure out why for the life of me. I did write a blog post on this last year. I've got a way to work around it. If you are working on an extremely huge node modules folder, I've got a workaround for it with a little bit of PowerShell script. But one of the things that we have found is TeamCity and Yarn play nice. We've recently started using Yarn at Agoda, and it's pretty awesome. And yeah, it doesn't have the same problems with TeamCity. So commit status publishing is the thing that I'll go into next, and then we'll have a break before we go on to the Octopus stuff. So commit statuses. So quite a while ago, Git systems started supporting this. It's supported by all the major Git systems now. What it basically is it allows for metadata information around success, failure, or pending to be updated on individual commit hashes within the Git system. So a lot of quality systems use this, and it's the best way to control things because you know, there is probably hundreds of thousands of integrations out there for GitHub, and they all use this system. So if you need to check whether or not something is passed, when it comes to validating things on your pull requests, I recommend using commit status because there's so much stuff that integrates with it. So we can see here, this is an example from a pull request in GitHub. Basically, we, you know, there was 3 things that ran. Out of those 3 things, 1 succeeded, 1 has in progress, and the last 1 failed. So you can do tricky things in your source control system. For example, in GitHub, you can elect for some of these to required to be passed, some of them that are optional to pass. An example is one of the projects I'm working on at the moment. You know, we've got a build that runs our unit tests, which is required, but we've got some end-to-end tests at the moment which are a little bit unstable, and they're not required to pass in order to merge into master. They're just like an advisory thing. And sometimes the guys will click in and they'll go, oh, actually that failed because of an environmental issue, but they'll merge it anyway, which isn't perfect, but yeah. So you may have some checks that are allowed to fail. So yeah. So the other thing I want to talk about is Git flow and branching strategies. So Gitflow was one of the it was one of the first branching systems widely adopted in Git. It's good if you've got long release cycles, and it was great 10 years ago, but we don't live in the past, so there's some better systems out there. For CD systems, it adds additional complexity, in my opinion. It's not required. Gitflow is great if you've got like multiple production versions out there, and this guy can't upgrade to the latest version, so you need to hotfix this older version, things like that. If you're dealing with that kind of application, I think Git flow is good. Git flow though does tend to, in my opinion, encourage developers to have long-lived branches, which is bad. So yeah, I don't know if there's any fans of Git flow here, but I'm sorry. So GitHub flow is in my opinion the best option for branching strategy if you want to go with a continuous delivery system. It simplifies the branching strategy with a focus on short-lived branches, moving fast and fixing fast. So GitHub published an article about GitHub flow, and I think it was like in 2006, and it took off pretty well from there. If you're using a lot of the advanced features that are in Git systems, like if you're just using Git from the command line and you never log into the website, then you probably don't want to use GitHub Flow because you aren't using enough of the new features that are in there. But if you are using things like pull requests, commit status publishing and things like that, it's going to be a good option for you, especially if you're releasing frequently. There's a good article that I've put in here. These slides will be available afterwards. We'll publish them to GitHub like we usually do, from Microsoft on GitHub Flow, which is kind of weird that Microsoft is talking about someone else's technology and complimenting it, but they've changed a lot these days. But yeah, I recommend checking out that article. We use GitHub Flow in most of our repositories at Agoda these days. So pull requests. Let's set up some integration. So the way that we do this is TeamCity has a feature called Commit Status Publisher. So I'm going to go into my build. So it's part of the build features. So if you go into build features and go add build feature, you'll see there's an option there for Commit Status Publisher. So what this basically does is TeamCity does all the work for you. I was working with one of the teams at Agoda a few months ago, and the guys had written a PowerShell script to do the commit status publish, and it was a real facepalm moment. You don't need to do that. It's all built in. It does things for you. You know, that's why we use systems like this, so we don't have to do manual work. So you can see here, it's worked out that it's got multiple VCS, or it's got an option here for having multiple VCS routes. So if you're doing something like fetching stuff from multiple repositories to build your application, you can publish your commit statuses to some and not other, depending on how you're using it. So and again, it's got support for multiple different source control systems. All the major Git systems support commit status publishing these days. So we're going to choose GitHub, and we need an access token. So this is quite common when we're dealing with GitHub, is it wants access using access tokens. So the way to generate these is you've got to go into github.com, and from memory it's in settings. So click on your user profile photo, go to settings, and then down the left hand side on developer settings, it's got personal access tokens. So just go into that. So again, it's settings from your profile, and then down the left on personal access tokens. And we're going to generate a new token. So if you click generate new token, it'll ask you for your password, and it'll ask you for a token description. Please put token descriptions in because, yeah, you want to know when you can invalidate them, what things are getting used for. Now you've got to select repo, and then go down the bottom and hit generate. Just go back to that. So you want to tick repository before you generate it. So that way we'll have the correct permissions. All right. So once you've got your token, click the copy button, and then go back to TeamCity, and we can paste in our token and press test. Now, if you copied and pasted from the website and you're getting an invalid password or authentic unauthorized message, it may be because you had a trailing space. So I would recommend putting in a notepad or something if you're getting unauthorized. Or it could be that you didn't check the repo button when you generated the token is another reason for getting unauthorized at this step.
Can you show me again how to open this TeamCity?
Yep. So it's in build features and add build feature. And it's the commit status publisher. And you've got to select GitHub. Alright, so you should see the post commit statuses to GitHub. Everyone okay with that? Anyone have any problems? Alright, well, what we'll do is we'll create some pull requests to check this out now. So to create the pull request, I'm not going to get you guys to git clone, make a branch, things like that. I did say all you'll need today is a web browser, so that's what we'll do. We'll make a change and create a pull request with our web browser. I think this is one of the cool features of GitHub. TFS also supports it, which I've used as well. I've had when you start to use these kind of tools and you're using the cloud-based ones, you can make them open publicly everywhere. And when you get that kind of versatility with your workplace, you can really do some amazing things. One of the companies that I used to work with in Australia, their offices, the only infrastructure they had in an office was a Wi-Fi access point, and of course people's laptops. They didn't have any servers, anything. Everything was cloud-based. And if you can get to a point like that with your business, it's quite cool because it means that you can work from anywhere. And a lot of these tools like GitHub and Visual Studio Online as well, or Visual Studio Team Services I think it's called now, you can code from the web browser. I had a scenario in the past where one of the projects I was working on a few years back, I got called and it was late at night, it was an emergency. You know, I was at a bar, I only had my phone on me, and I had to fix something. But it was okay, because I just used my phone to find the problem in source control. It was an if statement that just needed to be fixed. So from my phone, I was able to edit the code in the web browser, create a pull request, and the build automation ran against that, and then I committed the pull request to master, and then we had a CD system, so it went to production. And I called them back about 20 minutes later and said it's taken care of, you know. So I know Max from the mobile department, I know we've got at least one person here from the mobile team today. He's a big proponent of this, and he worked in a similar company previously that was all cloud-based. And it's not too hard to get to that level today, especially if you're a small business. A lot of these tools are readily available. So what we'll do is, if you just go into the README file, or sheet, we won't change any code, and just click edit the file in GitHub, and just add some text. So do this inside your fork, not in the main one. And then if we go down to the bottom here, you can see there's an option for create a new branch for this commit and start a pull request. And it automatically tries to pick a branch name for you. So you don't have to do the README, you can do any file in the repository if you like. I wouldn't recommend doing one of the code files unless you break it. And then when you've done that, click propose file change. that's going to take you through to the open pull request screen. So from here, we can see, you know, a little diff. If you are creating pull requests, please look at your diffs. A common mistake I see developers, they create pull requests and they don't think, and they end up with changing a whole bunch of stuff that their IDE automatically changed for them. And they just completely skip by and click create and don't look at the diff. So we're going to create the pull request, and that is going to kick off our build once we've got it active. So if we go back to TeamCity, now again we had the 60-second quiet time, so it will take a little bit of time for the server to catch up. I'm looking at the right build. I think I've got a problem with my parameters. Okay, I don't know if I accidentally sent that to everyone or not. Yeah. It should be refs, not ref. There's no soccer game here. Oh no, the one that I sent into Slack was correct. It's got refs, so if you copied and pasted from Slack, it should be correct. You're not? Did you just type what I wrote? Yeah. So, now that I've changed the references, I might have to create another pull request, I think. Yeah. Okay, I'll create another pull request. Or actually, what I'll do is I'll go into the other build that I've got. You might also notice on the branch specification there, I omitted the plus colon. Yeah. Now, the other thing that you'll notice is this guy. So once you start getting active branches in TeamCity, in GitHub, TeamCity will start to get the hooks in from GitHub, and it'll start to display this new stuff in the interface about the branches. So we can see here we've got all these different branches. So for request I'm working on, the VCS trigger hasn't triggered for that. one I prepared earlier. So this is another one of the builds I have in there, but it's a good example. So you should see on your pull requests these messages coming through now from TeamCity into GitHub. So out of the box, they aren't required. So you should see these come through, but you'll still have the merge pull request button. I've got two coming through here because I set up two builds on the repo. There'll probably be a third one that'll come through soon. But if you do want to add these as required, all you have to do is go into the settings in your repository and go to branches, and you can add a protected branch. So in our case, it would be master. And then when you're adding a protected branch, you can require status checks before merging, and then it comes up with a bunch there. So an important thing to mention here is that you have to have some commit statuses come through before these options are available. That's how GitHub knows that these guys are available here, it's seen some commit statuses coming through. So you won't have these options here until you've run a few builds and some data's come into GitHub. Has everyone got the commit statuses on their pull requests yet? Or are you guys still waiting for builds to run? We've got 23 in the build queue. Should have made more build agents, Tor. I should have made more build agents.
You should follow for visit the website. No one will the Saturday.
The release manager bot still runs on a Saturday. Yeah, if the queue's big enough.
But I think there are no queue.
Yeah, it's going to take a few minutes for that queue to clear out. Well, we might have a break now, guys, and just for 15 or 20 minutes, just so you can stretch your legs and have a coffee if you need to. I need one. And we'll resume after with, we'll go through setting up the .NET Core build and pushing it with Octopus.